In this problem, we're asked to find the magnitude of the force exerted on the charge number 3 by the other two charges. So I have a collection of 3 charges, Q1 down here, Q2 over here, and Q3 here, and we're asked to find the total charge in Q3. So let's do a quick sketch of the problem. So here we have charge Q2, charge Q3. There's going to be a force that Q2 exerts on Q3 that's going to point to the right. The magnitude of that force is going to be F23. We can calculate that using Coulomb's law. Likewise, there's a charge Q1. So there's another force on Q3 pointing downward. That's equal to force 1, 3. Okay, so we've got two forces that are applied to Q3, one from Q2 and one to Q1. And we need to add them up in a vector way in order to find the total charge that's exerted on Q3. So let's go ahead and do that. Let's calculate the force 1, 3. So the force from charge 1 on Q3. I'm going to calculate the magnitude of this force, and I know that because Q1 is negative, it's going to point down. So, just using Coulomb's law, I know that this is the magnitude of the force, and I can just put in the numbers from the problem. Microcoulombs for Q3. The magnitude of Q1 is 10 microcoulombs. Let's write that as 10 to the minus 6 coulombs to be consistent. This is over 4 times pi times 8.85 times 10 to the minus 12 coulomb squared newtons meter squared times the distance. Now notice the distance is given in centimeters. Again, I want to work in consistent units, so I'm going to change to SI units and calculate it using meters. So if I put all these things in, I find that the force that 1 exerts on 3, the magnitude of that force, is 125 newtons. And this is going to be, in fact, down. All right, let's take a look again. We've got another force between 2 and 3, so let's go ahead and calculate that. The force between 2 and 3 uses the same thing, Coulomb's law. Just put in the numbers. Again, the magnitude of Q3 is 20 microcoulombs. Q2 is 5 microcoulombs. This is over 4 times pi times epsilon naught, which is a constant. Times the distance, which in this case is 8 centimeters. Try 0.08 meters. Okay. If I put these numbers in, I calculate them, I get that this force is 140 newtons. This one's going to be to the right. So if I look at Q3, it's got a force to the right of 140 newtons, a force down of 125 newtons, and I'm asked to find the total force. Well, in order to get the total force, I just add these two things up in a vector sense and figure out the net vector. Well, essentially, the forces point orthogonally to each other. One's pointing to the right, one's pointing down. And so if I just draw 140 newtons this way, 125 newtons down, the net force is just going to be the vector sum of those two things. The magnitude of this force here is just going to be the square root of 140 squared plus 125 squared newtons, just using the Pythagorean theorem in order to add up the two orthogonal vectors. Now I can calculate this quantity and find 188 newtons for the total force. And this is the answer to the problem. The magnitude of the force, in this case, is 188 newtons. I get that by a vector sum using Coulomb's law.